continuing our data analyses, we want to do some more stats stuff. So let's create another cell, more stats. Let's do some basics like mean, median, and mode. So let's get a bigger variable to work with. Let's get a two-dimensional array, and let's have the first row contain all the integers from 1 to 10. The second row will go a little higher, so 2 to 11. That way there's the same number. And then 4 to 13 should be good. So let's look at that real quick. Let's run the section just so we can see it. Oops, there we go. So notice how, because of the size of my screen, it's broken over onto a new row. It's got columns 1 through 8 and then columns 9 through 10 here. So just like I expected, it's got, we can see the size, it's 3 rows, 10 columns. Now if I do something like mean of x, what I'm getting is the mean of each column. So I'm going to get a long one-dimensional array, has many entries as there are columns in my x, and each one will have the average, the arithmetic mean, so add them up and divide by how many there are, of each column. So we get, well, it's not a surprise, they're all off by 1 because of the way I built the array. So that's mean, it's by column. Now what if you wanted the mean of each row? Well, we can do the transpose the matrix and say, okay, instead of looking at each column, flip it so that the rows become the columns and the columns become the rows. Notice we're not changing the operation of the mean function. It's still looking at columns. The difference is we've flipped our matrix around so that what used to be the rows are now the columns. So then I will get different things. Then I'll get one entry for each of the rows from the original or the columns from the transpose matrix. Let's run that section and notice my answer now only has 3 entries. And they're the averages that used to be the average of what used to be the rows. And in the inverted matrix are columns. Whew. All right, let's keep going. Let's do median and mode the same way. We can do median of x. We can do median of x prime. Let's go ahead and run that. So each one we get a different median. Same with mode. Mode is similar. And let's keep going. Let's do adding up. So one thing that's very helpful in statistics and in MATLAB is to be able to add a bunch of things really quickly. So what we have is cumulative sum. Let's do this with a new variable actually. Let's say a equals, we'll do a one-dimensional array, 1, 5, 3, 7, negative 1. Negative 7, why not? So what I get in this case is a one-dimensional array, and what I want to do is add up one thing at a time, a cumulative sum, not just adding them all up, but adding up one at a time. So let's do a cumulative sum of A. Add one piece at a time. What we get is the output is going to be a one-dimensional array with the exact same number of values as A. Run section. So A is a 1 by 5, and the answer that I have here is also a 1 by 5. And what we have is at each step we're going to add that next value. So 1 plus 5, that's where the 6 comes from. When I add 3, I get the 9. When I add 7, I get 16. And when I add a negative, I go back to having the 9. That's cumulative sum. We can also do cumulative product. Similarly, we're going to multiply the numbers together. And at each stage, we report the current product as that entry. And let's see, what else can we do? Let's do same but multiplying. Let's do another thing, the sorting according to either ascending or descending. So I want to show you, let's say x equals sort by A, sort the matrix A, and I'm going to use the word descend in single quotes. So this is like a setting that we are giving MATLAB that says here's how we want to sort. Let's go ahead and do this. Run section. It's put the numbers from A in descending order. If we wanted instead to sort by ascending, going from smallest number to highest number, we would use the word ascend. And notice the color change. That closed single quote is how MATLAB changes it to a nice purple color instead of that error red color. So let's do that. Y should then be the exact same as X but flipped around. Okay, let's see how we sort something bigger than a one-dimensional array. If I have a two-dimensional, well, let's make a new column, a new array by putting together the X and the Y. So I'll use X. Sure, why not? Let's use X and Y. Well, let's use X and then the answer. So that's a little bit more interesting. X and Y are the same. They're just flipped around. So I've got X and I've got answer. Let's run this real quick and see what that looks like. So I have a two-dimensional array that I've called Z, creating a 2D array just to play with. And now what happens if I sort Z? Based on what we've done so far, you might expect that it's going to do some rearranging. But here's the interesting thing. When I run section, what it's done, let's compare these two real quick. Here's the original Z, and here's the sorted version. It has sorted by columns. So it's not rearranging columns. All the numbers from column 1 are still in column 1. All the numbers from column 2 are still in column 2. What's different is that within each column, the numbers have been sorted from lowest to highest in each column. So negative 735 is a smaller number than negative 7. That's why it ended up in that first row. So MATLAB is column dependent. Everything is columns. If you say sort and you have a two-dimensional array, you will get a column sort. It's sorting within each column. Okay? If you wanted to do something different, you could say, let's sort by rows. There's a whole different command for sorting by rows. So let's turn this one off. I don't need to see that. I do want to see Z again, and I'll say sort rows Z. So sort rows is our way of saying, okay, I don't want to sort the column, each individual column independently of the other. I want to sort the rows based on a particular column, but keep each row together. Why would this be useful? If you have student data, for example, I might want to order everyone in order of their overall grade, but I want to keep each student's record together. So if this is all of their data, it should go with. So let's see what happens. And we're going to look at Z and sort rows Z at the same time. So here's Z and here's sort rows Z, what we've got after each sorting. Notice that the 7, 5, 3, 1, and negative 7 are together. But what's been sorted is, by default, based on the first column. So it took the first column and said, okay, we're going to take the rows, keeping the rows together, and put them in order of their first column entry. So the 1 is smaller than the 7, it goes first, but the whole row comes with it. All right, you can also sort based on a particular column if you don't want to sort by the first one. So keeps each row together. By default, this is sorts by column 1. If you wanted to do something different, you could say sort rows, let's say, oops, sort rows Z, but let's use column, I don't know, 4 instead. So I'm going to turn off this one. I want to see Z and I want to see sort rows Z, but use the 4th column, run section. This one might be a little hard to tell. It's going to be the same as Z because in the 4th column, the 1 and the 105 are already in order. All right, but now you see how it works. Play around with it with a larger matrix and you can see what's going on. All right, that's all for this video. I'll see you next time.